Welcome to the AI for Good Summit webinar series. My name is Andrea Manara, and I'm from the ITU, the International Telecommunication Union, and I have the privilege of introducing today's webinar. ITU is the United Nations Specialized Agency for ICTs, and we are also the organizers of the AI for Good Global Summit, alongside the X Prize Foundation and in partnership with the 38 UN sister agency. The summit is co-convened with Switzerland. The goal of the summit is to identify practical applications of AI to advance the Sustainable Development Goals and scale the solution to achieve global impact. We are very pleased today to discuss Geospatial AI ML applications and policies, a global perspective in partnership with the World Geospatial Industry Council. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create and engage in discussions. For this, we will be using the Q&A functionality, which you can find at the bottom of your screen. There is also the chat functionality. Please make sure to set the message recipient to everyone and not just to panelists. You can select this just above the message box. Without further ado, I would like to introduce Barbara Ryan, Executive Director of the World Geospatial Industry Council. She will lead the session and she will introduce all other distinguished panelists. Over to you, Barbara.
Great. Thank you. Thank you very much, Andrea. Really appreciate. I really appreciate this and appreciate ITU's partnership on this event. I'd like to personally thank you and Reinhard for and your entire team, Bastian and Ida, for all the support that you've given us in the lead up to this. And I'd like to add my appreciation to those of you in the audience that Andrea just mentioned for joining this session. This will be the kickoff of a policy report that we are launching today at this event on geospatial AI applications and policies, a global perspective. But before we get into the specifics of that, I would like to just talk a little bit about WGIC before I introduce the panelists. So let's go to the next slide. First of all, the World Geospatial Industry Council is a global, not-for-profit trade association of private sector companies working in the geospatial ecosystem. Now, I have to say, to the best of my knowledge, this is the first trade association for the global geospatial industry that I know. Clearly, we've got really good examples of regional associations here in the United States. We have MAPS, the Management Association of Private Photogrammetrists and Surveyors. In Europe, we've got the European Association of Remote Sensing Companies. In India, we've got AGI, Association of Geospatial Industries. And so what we would like to do is, in partnership with those regional associations, just bring more global advocacy to the geospatial industry. I think all of you know that with this industry and in partnership with governments, this sector touches every person every day around the world. And so within the association, we take on a number of policy issues. You'll hear a little bit more from Arnaud Desmond about that. We will advocate on particular policy positions regionally and or globally. And then clearly, if you are a private sector entity working in the geospatial ecosystem, you are eligible to join WGIC. And what's so good about those people that are in the tent is that there are additional business opportunities working with other partners within WGIC. If we go to the next slide, what you'll see is our current members. We've got 3 categories: patron members, which are the largest companies in the world in this trade space; corporate members, which also include some of the largest in the world; and then for many of our startups and SMEs, the small and medium-sized enterprises, we've got an associate member category. All of the membership categories are based on annual revenue of the individual companies. And I guess I would say membership dues are our only source of revenue. This is an organization for and run by its members. We've got a really small secretariat, and so the members really set the strategic direction for the whole organization. Let's go to the next slide, because we also have partner organizations, and I specifically like to draw attention to ITU here. And again, thank ITU for hosting this event, but you will see other partner organizations that have an interest and sometimes a mandate, like WGic, in the geospatial industry, and the other partner organizations just have key interests in the effort. All right. I guess as a transition to our panel discussion, I'd like to pull out some highlighted text from the report. And what you will see are slides like this nested in the entire presentation over the next hour or so. These are, for a really technical term, these are blurbs from the report. But the one that we thought was just so important to kick off this entire series with is AI has the potential to disrupt every sector of society in both anticipated and unanticipated ways. This happens to be a quote from here in the United States from the US Congress, but I think this is as true here, as true anywhere in the world as it is here in the United States. So the next slide will actually show you the lineup that we've got. So after my welcoming address, Arnaud Desmond, Vice President of Maps at TomTom and Chair of the WGic Policy Committee, will talk a little bit more about our policy work and the official launch of the report. We'll go to an executive overview of the report by the report author and lead on the entire study, Lokendra Johan, who's founder of Ken Labs Inc. And then, as Andrea mentioned, we've got just a great lineup of expert short presentations from both WGic members and academia that will talk about their views on AI, some on the report specifically. In each instance, they contributed to the report. First, there will be Kumar Navalar, who is the Senior Director of Strategic Business Development at Maxa Technologies. I imagine, Kumar, you can correct me, but I think it's probably the largest private sector space agency, space organization company in the world. Jim Van Rentz, Senior Vice President of Regal International. Stephanie Leonard, Head of Traffic Innovation and Policy at TomTom. Siva Ravada, Vice President of Product Development at Oracle. And last but not least is Professor Shashi Shekhar, who's a McKnight Distinguished University Professor from the University of Minnesota. Arnaud will bring everything. I'll moderate the discussion among the panelists, but then Arnaud will bring everything home at the end as we end this next hour and a half. So again, thank you everyone for joining this session. Please ask any questions in the chat box, and Arnaud, I'll turn it over to you. Thank you very much.
Thank you. Thank you for the introduction, Barbara. So hello to everyone also from my side. Thank you for joining this webinar. I'm really very glad that we can organize this event as part of the AI for Good series of ITU. I think it really has a good place here. And I also definitely want to thank the ITU organizers for the willingness to co-organize this webinar together with WGic. So as mentioned earlier by Barbara, one of the committees of the WGic is the policy committee. And so within the WGic, we cover policy issues impacting the geospatial industry in one way or another. So we want to engage with stakeholders in the private sector and the public sector, also in academic worlds, but we also want to engage with civil society at large. We want to do this around specific prioritized themes. And these are specifically themes of interest to the geospatial industry, but also with a very high relevance for policymakers and civil society. So to achieve this, we engage in high-level policy desk research around these prioritized themes. And we combine this with surveys and in-depth interviews with the WGIC members, but also with external subject matter experts. The outcome of that research is then documented in a policy paper, and the policy paper, the outcome, the results are then shared in subsequent workshops and seminars like this one with the WGIC membership, with the geospatial industry, with the technology sector, with policymakers, academics, and so on. So last year, we did conduct policy research and did also publish a paper on personal data protection and privacy in geospatial. This includes a high-level outline of the privacy legislation across the world and also its impact on the geospatial industry. So this paper also includes recommendations for policymakers. It includes guidelines for the industry itself on how to proactively address the privacy concerns in society, and doing this in full compliance with data protection legislation. So I definitely encourage all of you to download that report as well from the WGIC website. Now, this year, we decided to focus on artificial intelligence and machine learning. Over the past few years, we have experienced rapid growth in AI, ML applications across various technology domains. Especially in the geospatial domain, we see a very wide range of AI, ML use cases and opportunities that are starting to emerge. And the application of AI, ML in geospatial has a lot of promise in terms of innovation, in terms of realizing breakthrough efficiency gains, in also addressing previously unaddressable, unsolvable problems. But with the further exploration of this apparently quite huge potential, there are also obvious challenges related to data privacy and personal information, related to intellectual property control and intellectual property protection, but also in relation to ensuring a fair competition and a level marketplace. There are also ethical concerns related to socioeconomic equality, racial or gender biases, etc. So what we notice is that confronted with this very fast-paced AI/ML revolution, that public authorities struggle with their role in policymaking and their role in regulating this fairly new domain. So what we want to do with the policy committee is we want to strengthen the public debate and also support authorities across the globe in developing an effective but also balanced AI/ML policy framework. Such a framework should enable the geospatial industry to maximize the benefits of this new technology revolution, but also should help also to secure at the same time positive impact on society in support of the UN SDGs. So in the first phase, the policy committee decided to develop a body of knowledge on the current AI/ML practices and experiences in the geospatial industry, and also document the emerging policy domains and challenges by tapping into the accumulated experience of the WGIC membership, but also complemented with interviews with opinion leaders, technology leaders, and leading academia. So for that purpose, we did engage Lokendra Johan to conduct both the member survey as well as the desk research. Lokendra studied at IIT Mumbai and also at the Georgia Institute of Technology. He worked several years as a consultant and an associate, both in India as well as in the United States. And he always worked in initiatives at the crossroads of technology and economics. Lokendra is an expert in AI and worked among others at the Qatar Center for AI to lead the work on ethics and governance of AI. He also co-authored the National AI Strategy for Qatar. Lokendra is also a serial entrepreneur. His latest venture is the start of QN Labs, which is focused on research in AI and computational sciences. Although he's not part of the academic staff of the University of Minnesota, Lokendra also worked very closely with Dr. Shashi Shekhar, who is also part of today's panel. So we are very happy today to launch the official publication of the policy paper on geospatial AI ML applications and policies, a global perspective. I'm really confident that this paper will serve as a relevant body of knowledge and will also feed the debate on policy development and best practices and guidelines for the geospatial industry around AI ML. Please use the link on the screen now if you want to download this presentation. I really encourage all of you to do so. So I look forward to a very interesting introduction of the policy paper by Lokendra and also the subsequent panel discussion. And I hope that this panel discussion will also be followed by a very lively Q&A session. So let me now pass the word to Lokendra to talk more about the content of the paper. Thank you.
Hi everyone, I'm Lokendra Johan, and thank you so much, Arnaud, for such a nice introduction. Now, I would definitely, I guess Arnaud and Barbara have already thanked ITU, but I again want to express my gratitude for organizing this event and getting this report launched in such a good venue. I think this is the most appropriate place for this. Now, I'll start with the, just a sec, let me. So, yeah. So, other thing like, so I'll be giving an overview of the report as it has been told. I wanted to start with thanking Professor Shashi Tharoor, who's been a mentor to me and guided me through the whole process of the whole study and the writing of the report. He's a leading luminary and leading scholar of geospatial data analysis for the last 3 decades in the world, and you'll hear from him later in the anyway. So then I want to thank like all the participants because who participated in the interviews from both WGIC members and outside communities. So that's, and finally, like I want to thank all the members. Finally, I want to thank WGIC for providing me this opportunity and also providing the policy committee for providing me the necessary oversight needed in the process of the study, and their feedback was of real great value to me. Yeah. Sorry, just a sec. Yeah. So in terms of the how we did the study, the methodology was quite simple. Arnaud also mentioned briefly. So broadly, we did desk research, basically documenting information about geospatial industry and GeoAI in specific. Also did a technology landscape review kind of thing for AI and ML technologies in general. And then the most importantly, the most important part of this research involved doing a very thorough regulatory landscape survey of all the AI policy and legislative efforts happening around the globe. Then the second and even more critical part of the study was consultations, where I conducted interviews with a lot of the WGIC members and even subject matter experts outside the WGIC committee. We looked at different GeoAI use cases which are there right now, how they define success, lessons, and concerns, their views on what kind of policies should be there, and a lot of different topics associated with them, with this. And finally, it was about distilling it all into a report which is getting presented today. Now, so in terms of the people interviewed, so as we said, as Arnaud mentioned, we wanted to first tap into the accumulated knowledge and experience that WGIC members have in the geospatial industry and community. So, so we talked to 21 WGIC member experts, 21 experts from WGIC member companies. And then we expanded our reach to make sure that we are able to collect perspectives from all different segments of stakeholders of the geospatial industry. So which is government, academia, non-profits, and startups. Then the other thing we wanted to make sure was that to ensure that the study is globally representative, and not just in the case of, okay, you cover all the continents, but also from the perspective of covering all the large markets, at the same time also ensuring it's not just all the developed countries. We also looked at developing countries and also countries which are very small in size, like Singapore and Qatar. Yeah. Sorry, I'm just having a little bit trouble with the moving the, sorry. Yeah. Now, before I get started, I just wanted to give a overview of like what I mean by AI and GeoAI. And I tried to come up with a simpler definition. There are a lot of definitions going around for AI in general, and here I'm trying to explain it in simple words. So broadly, AI is basically a kind of software, and usually in software, when we're trying to solve problems, what you do is you start with a set of rules to be followed, and you have data which goes in as inputs, and then you come out with answers. Now, in case of AI, what happens is you start with data and answers, or labels you can call them. So broadly, you start with them, and then what you try to do is you come out with rules, which then can be used for making predictions from AI. So that's how it works. Now, when we talk about geospatial AI or GeoAI specifically, the main things are like use geospatial data, which could be location, time, spectral bandwidth of the satellite use, etc. And when we talk about answers or labels, it's like information, okay, how close two things are, or a label describing what particular object this is, whether that's let's say whether that's a road or not. And when you move out of the process, what you come out with is the rules, which basically would be that, okay, if there's something which, okay, you're looking at a satellite image, and if say there's something which is very linear in shape and keeps connecting with similar objects at different places to make a network kind of thing, then it's probably a road. Yeah, so that's those are the kind of inferences, the rules which come out, because then those rules can be used for making such predictions again and again at a large scale. Now, what do we mean by geospatial? So here, like I wanted to say, there's a very famous saying in the geospatial industry which says everything happens somewhere. Now, the main point is that almost everything which happens in the world, or almost every data piece in the world has a location tag associated with it. And the geospatial data has been increased because data is increasing in general everywhere. So geospatial data has been increasing exponentially. And whether that's a lot of new kind of data sets are also coming into play. So yeah, we had traditional geospatial applications around maps and all, which includes cadastral data about, let's say, land ownership, etc. But then now even IoT data streams have a location signal. There's a lot of user-generated content getting created all the time, like when people any kind of mobile phone traces, or whether, let's say, when you write a review about your favorite restaurant, all of that has a location tag, and it can be considered as a geospatial data point. Users of LiDAR has been increasing like anything, especially when it comes to HD maps. So that's another space. Navigation people already know about, and one of the very important sources of geospatial data is satellite data, and the number of active satellites has been increasing like anything, and people expect that the number of active satellites in the orbits would go almost tenfold in next 10 years. So that just gives an idea like how fast the data has been scaling up or increasing in case of geospatial. Now, so if I were to summarize the whole study into 1 or 2 slides, like this becomes, so this is one of the most important slides. It's like, we, based on my discussions with all the people, when we talked about all the different GeoAI use cases and how it has been, what are the factors which are changing and how things are evolving. Now, so the general consensus came out to be that we have around, let's say we can classify all the use cases into 3 broad categories. One is descriptive, predictive, and prescriptive. And all of these also fall into line in that, okay, what is possible today, or what are the use cases people are working on right now with live systems? What are the use cases which are which people expect to be in existence within 2 years or so, and what are the expectations of people in a slightly longer term, like 5 years and beyond. So, so what we mean by descriptive is like, okay, let's take the example of satellite imagery. And so when you're looking at a satellite image, and you use AI algorithms to be able to find, okay, whether the object being observed is that a farm or a building or a road or a vehicle. So a lot of object detection based use cases are there right now, and AI algorithms have been getting good at that. Moving forward from that, what we do expect is use cases in which the outputs would be much more predictive. So what I mean here is like beyond object detection, I think the big move which happens here is from object detection you move to change detection, which is where you could use the learning from the change detection to be able to predict things, what will happen. Let's say if there's an adverse event like excess rain or lack of rain, then how would it impact the crop in that season on that area? Or similarly, like what would be the expected cost of repairs in a district or a state for the roads assets they have, and etc. So these are the kind of predictive technologies which are expected to come into real live uses across the globe. And then we come to moving forward, like we come to prescriptive, which is where like the recommendations would become very specific. It's not just that the AI systems would be able to identify or predict what can happen, but they will also be able to give very specific recommendations that, okay, in this particular case, do this thing. So like say, it's not about overall cost of repairs. It's about, okay, there's a specific need of repair at this particular location, at this bridge, or maybe because of these conditions observed, we could expect these kind of pesticides to come into, would be required for this many area. So it's just like very specific recommendations coming into the play. And let me also take a step back. Now, what happens is this is about geospatial industry as a whole in general. So there are companies which are a little bit ahead on the ladder. There are companies which are yet to start on the AI ladder. So that, but then that's, I guess, the case for almost every industry. So that's how it has been working. Yeah, and all this is happening in the backdrop of how geospatial data is either landscape is changing. So I already mentioned that it has been increasing exponentially, and it's increasing in all dimensions. You see improvements in all dimensions, whether that's slowly the quality is improving a lot, variety of the data is improving a lot, the coverage in terms of global coverage is increasing fast, frequency. Now people can get daily satellite data. So this is, and all this is happening again while the cost of data acquisition is decreasing. So this is the broad overview of like where geospatial industry stands as per the consensus we could gather from the people who were interviewed. Now, so as I mentioned, we also did a quick AI policy landscape survey. So we looked at 13 jurisdictions, so primarily European Union and 12 countries. And what you can notice is, so so almost every country has, in fact, right now there are around 50 countries in the world who have some kind of AI policy or strategy document. But so we looked at the 13 of these jurisdictions, and the two main parts to this. One is what's happening on the AI and AI policy front, and other was like AI is enabled by data. So we also looked at data protection laws, etc. And almost every one of these country jurisdictions had some sort of data protection laws also. Now, in terms of actual laws which countries have, so there's some amount of legislative activity, but there's that's why, but not a lot of laws that have been enacted already, which is where, as Arnav mentioned, this is the right time for a body like WGIC to take a sense of like what's happening and how we could try to make best recommendations for even to the governments on or policymakers on what kind of policy should they go with. Now, in terms of recommendations, we have tried to categorize the recommendations broadly at the three segments. One, what an individual organization can do. So when, as a company, what companies can do is, there's a growing consensus around what do people mean in terms of the ethics and governance of AI. And those are broadly about privacy protection and making sure the technologies are fair and equitable. So that's, so companies would do well if they are able to align their AI development plans with this, so that because that this becomes a good faith effort to self-regulate, and which also increases the trust in their own brand and the geospatial industry as a whole, and hence and more importantly, it also keeps them prepared when new laws regulating AI come into play. So there won't be much of surprise left. Then it comes to government. Now, for government, the main message is that governments should not try to restrict innovation. We should let people, entrepreneurs, and innovators try a lot of things. But at the same time, and the other thing which governments have to make sure that AI as a technology has been developing very fast and it's evolving very fast. So yes, the regulations have to be easily enforceable, but at the same time, cognizant of the fact that things are changing fast, and there should be some, the design of regulations should also be in some kind of evolving format, because there are things which might not be possible for even large corporates today, but they become, but 5 or 10 years down the line, you would see anyone with a mobile phone would be able to do those things. So that's it. So that's why that has to change. And finally, when we talk about geospatial industry as a whole, so they can, in terms of industry cooperation, the things that geospatial industry has to work on is classifying use cases by the risk potential of harm, so that that can enable calibrated policy responses from the governments. And as I mentioned about the self-regulation parts, so that involves like, okay, creating tests and checklists for self-audit of GeoA applications, so that it becomes easier for governments also to understand, okay, these are the needs, this is how we can move forward with the coming up with new regulations. And finally, almost all of the people interviewed, they stressed a lot on the need of having a lot of open data sets for training purposes, and that's a very important piece. So having open data sets for training purposes, having benchmarks for performance, etc., and tests for performance, so that finally we end up creating a level field for everyone to compete, and the best applications can emerge out as winners. So that's the main objective of, that's a summary of our recommendations. Now, I'll hand over, thank you so much for bearing with me. I'll hand it over to Barbara now, who will take it from here now. Thank you so much.
Very good. Thank you. Thank you very much, Lokendra. Listen, this will be short because I introduced the speakers before. So let's go into the AI expert panel presentations and discussion. Each speaker will give you, maybe 4 or 5 or 6 minutes on their particular views. And rather than me come back each time between the individual speakers, I would just ask the individual panelists do a smooth transfer handover to the next speaker. So just one more time, in the geospatial domain, a wide range of AI, ML use cases and opportunities emerge with great promise in terms of innovation, breakthrough efficiency, gains, and addressing previously unsolvable problems. And particularly with the first three speakers, Kumar, Stephanie, Jim, and Stephanie, you're going to hear about some of those individual use cases. So, Kumar, I think it is over to you. Thank you.
Thanks, Barb. I will build on some of the things Lokendra mentioned. The first thing is I represent Maxa Technologies. We are in the space-based remote sensing industry. And it's one of the key sources, as Lokendra mentioned, for Geo AI. And we have been a leader in pioneering the spatial resolution, spectral resolution, and so on for the commercial remote sensing industry. And if you look at the new space developments you're looking around in the industry today, not only we are talking about electro-optical satellites being launched at multiple resolutions, multiple spectral bands. Now we're also looking at multiple modalities like RF, radio occultation coming along. So this is a key input into the AI applications for geospatial applications. So now let me step back and talk about the various aspects of the AI we look at. The framework Lokendra mentioned, the descriptive, predictive, and prescriptive. So a lot of the AI ML today is focused on descriptive. What are you seeing in a given image? So my comments will be based on mostly on the remote sensing data. So what are you looking at in terms of the various objects in a given scene? And then the next evolution where I believe the industry is heading to is predictive. What is going to happen in a given area? This is something we're already seeing few companies doing, where, for example, they're looking at the number of cars in a parking lot and trying to basically correlate that with financial patterns or economic patterns. Similarly, people have been using predictive analytics for socioeconomic and environmental trends as well. The one where we are headed is basically trying to mimic human cognition. That is the prescriptive part of it, especially when you're talking about evolving scenarios, both on the civilian as well as the military sides for geospatial applications. This is where the prescriptive application becomes very interesting. One of the other aspects that's key for geospatial companies is the trust or being ready for AI. And AI readiness has different aspects to it. Trust is something I think one of our panelists will talk about more, but it's more than that. What are the aspects of AI you can actually use? Because different applications will provide you different results with these AI technologies, and you should be cognizant on what is it you're trying to do with these kinds of technologies. And then when you step back and look at the remote sensing industry, the big data, I know that term has been dropping off in the last few, I would say especially a few months, but we still collect a lot of big data. And we're talking about terabytes of data every day, close to petabytes, a few petabytes of data every year. So the key thing is, how do we actually get those actionable information and then act on it? And this is where we are looking at AI ML as being a key enabler for those kinds of analysis. The other one that's also becoming very relevant for us is the latency from the data collection to when you can have the answers in your hand. In the past, now I'm talking maybe even 3-4 years ago, the time frame from when you collected the data, you analyzed an image, and you got your answers could range in days. Now what we are looking at is multiple applications where the information needs to be ready in minutes. So thanks to the developments in cloud computing and other technologies, along coupled with the Geo AI applications, now the industry is heading towards leveraging AI to basically start providing these actionable insights in a very timely manner. Harsh, can you go to the next slide? So with that, I just want to highlight some of the aspects of the report. There is a high demand for geospatial AI ML applications, but the risk is being the training data. If you look at our satellite data, the key aspects is it's not only the volume of the data, but also the veracity of the data. As you take the pictures on the same location, we have changing image quality because of atmosphere and other conditions. So you need to actually train these algorithms so that you're able to predict an object consistently over time and over geography. So the need for AIM applications and associated training data is a critical part of the consumer tech industry. With that, what I'll do is I will introduce you to my second panelist, Jim Van Rentz, a technology enthusiast. He's our Senior Vice President of Regal International. So Jim, the floor is yours.
Thank you, Kumar. Appreciate that very much. And hello to the world out there. Thank you for joining us today. And if we could go to the next slide. So LiDAR is not as well known as satellite imagery. Satellite imagery is well known to the world. All of us these days seem to rely upon some satellite image every day. LiDAR is a little lesser well known, but it is an important geospatial technology for the remote sensing world. And like many of the remote sensing technologies, it is very big data. So an example is that for the 3DEP program here that's created the national map of the United States of America, it is estimated that in terms of information extracted from these point clouds, that less than 20% of the point cloud is used. So from that big data, it's critical that we extract the important information, but we also need to use more. As Kumar mentioned, high resolution, high density, high precision is very, very important. And so I've tagged that high fidelity. LiDAR provides accuracy and completeness of geospatial data. What it does is it calibrates the integration of other technologies, and this really moves us down the path to higher fidelity data and the critical visualizations that are more true to the world. High fidelity data is a prerequisite for machine learning techniques. So what it does is it represents the real world and it facilitates machine learning techniques that feed into AI. So for Geo AI and ML to be effective and have a faster adoption rate, high fidelity information that allows these algorithms to see the assets without distortion, and this will allow them to learn correctly and move us in the right direction. Someone in the audience talked about a global standard. Well, data veracity, reliability, and trust is critical. The need for global standards is paramount. As the technology and the data change, so too must the standards change, but they must be, in all cases, authoritative and relevant. Next slide, please. So, machine learning will handle many of the mundane tasks very effectively. Artificial intelligence will provide us with the options to analyze and assess the correctness of the models that we use to define our world. So authoritative surveying and mapping information is a planning requirement. And for example, geospatial location data is at the heart of smart cities. Predictive models will be crucial for city managers and planners. The Internet of Things is a part of this new approach. So for example, high fidelity geospatial data and the Internet of Things sensor networks allow for predictive modeling on routing, which is critical to emergency response. So we are really excited to see some of the coming innovations that's arriving at us. We're doing a lot of work with universities and small startups to be able to move this along. And so we're quite excited to see all these changes coming. And at this point, it is my honor to introduce Stephanie Leonard. Stephanie is with TomTom. So Stephanie, take it away. Thank you.
Thank you very much for the kind introduction, Jim. And Good morning, good afternoon, and good evening, everyone. I see in the chat box with people from all over the world, which is fantastic. So yeah, if you go to the next slide, please, and the one after that. Thank you. So I've only got 5 minutes, which is impossible to really go into this topic, and we've already had a really nice overview from different perspectives in the presentations before. But what I would like to do in my 5 minutes is just give you an overview on how we use AI in TomTom today and how I want to use AI tomorrow and future applications. And then finally also go into the kind of regulatory landscape of artificial intelligence, just to kind of give some teasers of what we're going to be discussing in the roundtable. So just before I begin, so TomTom, of course, is a location technology specialist. So we provide digital mapping, navigation software, and real-time traffic information to millions of different connected devices all over the world. And of course, AI is really important for us because it can really power the generation of products that we have. So to give you 3 kind of key examples of how we use AI and machine learning today, one would be, of course, any kind of automated process with our kind of map production process. So anything you can automate, you can make it more efficient. AI and machine learning, of course, is massively powering that. Also, any compliance related to privacy, is a huge enabler for that. And of course, that's very much linked to this AI topic as well. In terms of actually product-specific elements and product analytics, there's a lot of advantages. So to give an example, we can use machine learning and AI to actually detect when actually there's a road closure on the road based on using our probe data and running algorithms on that. So there's lots of really cool features that you can put in a geospatial context by using AI and machine learning. And then last but not least, it gives us great insights into our products and actually better understanding where there are weaknesses and gaps and how we can actually improve them and take them to the next level. But looking at AI tomorrow and in the future and actually how we can really improve this, another examples of where we're interested in. One, the increased use of satellite data. So that was something which Lakendra had introduced in his kind of overall summary. We hope that actually AI and machine learning will actually make it easier to use that satellite data. But not only, we also feel that actually this kind of automation aspect of our map making process will be even easier with higher levels of AI and machine learning. Actually updating our map within hours rather than having it a little bit longer. And there's a huge potential to actually increase the speed of that process. And then last but not least, a very interesting area is to do with actually driver behavior analytics. So for example, looking at driver profiles, being able to predict actually where a driver might want to go. So lots of interesting space in this area. And if we can go to the next slide. So in terms of regulation, and this is a topic where I'm a little bit close with my current role, I wanted to use the picture here to kind of indicate that there's a careful balance, I think, that needs to be achieved with regulating AI. It's a very sensitive topic all across the world. And one of the main open questions is, how on earth do you regulate something like AI? I think as some of the previous speakers had mentioned, it's a kind of a topic which is constantly evolving, it's constantly growing, and a starting point is, can you regulate AI, and if so, what aspects do you look at? And at least in Europe, what we see is that there's a growing perspective on actually looking at the different use cases of AI and trying to distinguish if there is a high risk to the general population and to citizens, or there is a low risk. Risk in terms of their safety, their well-being. So the argument, at least in Europe, is we should regulate AI applications where there's a high risk to the citizens, but if there's a low risk, then maybe we don't need to regulate that market. So we really need to look at the use case approach and not bundle everything into one bucket, which we think actually is quite a good approach. The second aspect of regulation, which is important, is actually how we define AI, because AI is often used in many circles as a bit of a buzzword. It's commonly used across many cases, and the risk that we see as a company is that if we regulate on AI, which I think we're going that direction, if we don't get the definition right, then you actually risk regulating a much broader ecosystem of products and services than those that are actually using AI. So for us, it's really important that we get that definition correct. And please check out the report, because Lakendra did a very good job on trying to nail down that definition. Then third point here, in terms of horizontal regulation or vertical regulation, one thing we have to take into account is that for a lot of sectors, like the automotive sector, they already have existing regulations in place. So a big open question is, okay, if we regulate AI, should we actually use the existing regulatory channels for sectors that have that? Or do we regulate across sectors in a horizontal way? So from our perspective, we just need to decide which one we should do, because if we regulate in both approaches, you have the risk of double regulation and then actually kind of potentially a regulation that overrides each other or duplicates, which could be a bit of a headache. Then fourth point, access to data. You can't really talk about AI without talking about data. You need huge volumes of the stuff to be able to run AI applications. So of course, if we're going into a perspective of regulating AI, then we need to cover access to data. And with that, sorry, put a reminder on here so I don't go over time. So there we need to look at access to data from a fair, reasonable and non-discriminatory perspective. And then last but not least, the ethical considerations. So of course, AI and ethics is a big topic. We can go over this into the discussion panel, but just to introduce you to the topic a bit. The ethics of AI, this is looking at the impact on privacy and surveillance, how much that can be respected. Is looking at bias and discrimination if AI is being used in the wrong way. And the third point, of course, decision-making, right? So is the AI application that you're running going to have to make decisions? And are those decisions going to have any kind of moral consequence? So the classic example of the autonomous car, it has to maybe decide what object it has to hit or has to avoid. How is the impact of AI in that? And how is the impact of moral impact? And that's the two things are very much close together. So I think with that, I can have my last slide before handing to Siva, which is just an extract of the report, which says, of course, organizations should be leading by example and actually building up the faith and the norms and the ethical use of AI so that policymakers and customers and citizens can actually trust the AI that we're building, especially in the geospatial industry. And with that, I hand over to Siva from Oracle. Thank you.
Thank you, Stephanie. Good morning and good afternoon, everybody. I represent Oracle and the WGic, and Oracle has been in the spatial database business for more than 20 years now. And then we also have a lot of experience in bringing spatial technology to location intelligence and business intelligence applications. So one of the things we learned in developing these products is how to make the technology accessible to non-spatial experts. So usually when a new technology develops, it can go in a couple of different directions. One direction is the technology is really great and then it develops so that it's only useful for very large corporations or very large agencies. On the other hand, you can develop the technology to be very useful for a broad set of users and a broad set of applications. For geospatial AI, right now we are at a stage where we can set this direction. So we want to make it so that when we, in the next 5 years, at the end of the 5-year or 6-year time frame, we will have the technology, geospatial AI technology that is very useful for a broad range of customers that can be really used by people all across the globe. So with that, I want to get into some of the specific points where we can focus to make it broadly accessible. So as some of the speakers have already mentioned, and I see some of the questions in the chat, people are already asking these questions. So one of the basic fundamental things in AI ML is developing data models. So I already see somebody asking a question about if you have a data model developed using data from some cold countries, can we use the data in some other country? So coming up with a data model is very important. And it takes a lot of time and effort to build a data model. And these data models can be very specific to different industries or can be very specific to different geographies. Since it's a very time-consuming process, it should be we have to make it so that it'll be easy to share these data models for like applications for similar geographies. Right now, there is no sharing mechanism for these data models. People develop their data models and then use them. and then somebody else wants to solve a similar problem, they start from scratch. So we need to get over this problem and then try to come up with some interagency level or national level or local government level establishment so that there is a way to easily share these data models. And then as Kumar also mentioned, training data is also very important. And then training data, a lot of the smaller agencies, it's very hard for them to get training data. If you're a large corporation, you might have access to large sets of images or whatever data that you have, and you can train your models very well. But if we're talking about smaller local government agencies, they might not even have access to a good set of training data. So again, if you're solving similar problems, it'll be very nice to establish these data sharing mechanisms and data trust so that people can, who have very good training data, they can publish the training data and then make other people take advantage of that information. And then, so some of the experience that we had over the few years is when we build these new technologies, a lot of the times you make the tools that you develop in that technology, in that area, the tools are only useful for experts in that area. If you look at location intelligence and business intelligence, and then how spatial technology is integrated into these technologies, into these tools, 5 years back, if you wanted to use a business intelligence tool and then use some spatial technology into that, you would have to have been a real spatial expert. But now we are at a stage where people who don't have spatial experience will be able to use these location intelligence and business intelligence tools. So similarly, since we are now at a stage where we are developing a lot of these AI tools, we have to really work hard to make sure the tools that we develop can be used by non-AI experts. That is the only way to make the whole technology accessible to a large number of user groups. And then we have seen some of these initiatives already in the United States. A lot of these Department of Transportations are already talking about establishing some mechanism where these different state Department of Transportations, they're going to share the experiences that they have, lessons learned, best practices with other departments of transportations. So that similar agencies, whatever they learn, they can share that information and knowledge with other agencies in similar geographies so that data, all of this knowledge sharing happens very easily. So one of the big problems today is we don't have enough skills in the workforce to understand AI technologies and to solve problems using AI technology. So that's one of the things is we have to reduce this knowledge gap and also at the same time build the tools so that people who don't necessarily have the AI skills will still be able to use the tools to solve these problems. So next slide, please, Harsha. So this is one of the main things from the report is because geospatial AI can affect people from all walks of life. So these decisions can be made to different geographies so that we can do sustainable development and growth and preservation of natural resources. So spatial AI can be used in a lot of these applications that are good for the earth and good for the whole population. So with that, I want to introduce Professor Shashi Shekhar from University of Minnesota. So he also is my PhD advisor when I did my PhD long time back from University of Minnesota. So now over to you, Shashi.
Thank you, Shiva, and thank you for a very warm introduction. And Shiva, in many ways, kind of took our group towards spatial databases. That was mid-90s when this whole area was starting. And it has evolved from the spatial database world. You know, we dabbled into spatial data mining, and now quite a few projects are related to Geo AI. So I'll share an academic perspective, just try to add to the points that Shiva and others have made. So we can go to the first slide. So first, as a field, you know, Geo AI draws on many disciplines. Of course, artificial intelligence often was intersecting with computer science and cognitive science. But in addition, machine learning in recent years has drawn upon statistics. And then, many of us in this room already know that if you do one size fit all statistics, it doesn't work very well with spatial data, because spatial data has many properties like autocorrelation, which violates the assumption of one size fit all statistics and machine learning. So that's why we need to also draw upon spatial sciences such as spatial statistics or remote sensing and so on. So, so this is a field where we draw upon ideas from many places. We'll go to the next slide. And so one thing I'll share that even though I didn't have any formal training in spatial world, but at Minnesota through projects over the last 30 years, I have slowly learned, and also from brilliant mentees like Shiva and Lokendra and so on. So most of the project work and experiences we try to summarize for a broad audience recently. So the book that's shown on the left, Spatial Computing, MIT Press published it last year. And it's written for a very broad audience to give you a glimpse of different slices of spatial computing, such as remote sensing, GPS positioning, spatial databases, spatial data mining, cartography, and so on. Right? So here I would like to just share a few highlights of the field. Click, please. Right? And as I said, also thank you for all the sponsors, different federal agencies and industry. Click, please, to the next slide. So first, something really changed between last century and this century. Some of us probably have realized it, but we want to know that everybody to know that spatial has now become ubiquitous, and it has become so critical that people believe that if GPS and other things stop, it will really bring many things in the economy to a halt. Because GPS is not only used for location, it's also the reference clock for almost all critical infrastructure today. So this has become very, very essential for our lives. There are billions of receivers already, and they're growing very fast. Click, please. Now, they're also generating large amount of location traces. So for example, TomTom uses GPS traces from cars and cell phones to estimate traffic, but there are many other use cases. Try to pick routes which reduce emissions or energy. You probably heard Google Maps is going to introduce a route selection based on emission by the end of this year. The total value of this data, about 2012 was estimated to be 600 billion per year by last year. So very, very valuable. And if you want to see a more recent estimate, so GPS was open to public in early, in 80s, and it took about 10, 20 years to realize this potential. Remote sensing data is opening up now, right? So about 12 years ago, USGS gave away some of the remote sensing data. And in recent last 5 years, even the storage and communication bottlenecks have been removed. So Amazon AWS Earth, Google Earth Engine, NASA Earth Explorer, they are making all this data very, very available. So a National Academy report 2 years ago estimated the value of remote sensing data in next 5-10 years to grow to trillions of dollars per year. Again, large amount will come from energy saving and many other societal applications listed in United Nations goals. Smart cities is certainly another application. So what does AI bring to this table? I mean, clearly, geospatial right now is much more valuable than AI, but AI does bring some values, one of which you have already heard. We can, if we want to make maps, AI allows us to scale up. You can make it cheaper, faster, bigger. And I'll give you two examples. One is, US National Wetland Inventory. In last century, it took $400 million in 40 years. Clearly, we don't have that kind of money anymore. And we need to automate some of these processes. So you can use machine learning to convert satellite imageries to land cover classification or detect objects. Right? Another example, which is actually in practice, is the figure which is on bottom left. I don't know how many of you recognize this picture. This is from Global Agricultural Monitoring. Every month they produce a report. And this is a collaboration of 82 countries. So they start from remote sensing, they run machine learning to classify crop health. Then they do ground truth checking and clean up and publish the report. And here you can see, for example, about 2 weeks ago, most of the world crops are doing fine, except south of Brazil, when you see the red color and so on. So this can give you early warning about food crisis. And if you remember the Arab Spring about 12 years ago, a lot of people trace that back to food shortage. And the community came together to say never again. And this is a great application of AI, machine learning, and remote sensing to solve one of the food security issues for the world, right? Let's click again. And there are other problems as well. AI delights itself to solve inverse problems. And there are those in our world as well. For example, I'm giving you a map on the bottom right, and I can ask, well, given this map, can you tell me where am I? Those of you who have visited Minneapolis can probably recognize some features like Viking Stadium or Horseshoe Falls and Anthony Falls and so on. But anyway, I mean, this is a very critical question in security. An image comes in, a video comes in, you want to know where it was created. Click, please. And, and click one more time. And there are many other sort of applications. For example, fake news, a lot of times they are using maps, and you want to check whether the map is actually describing the location which is covered by the news. And there are a lot of times they actually create fake maps, right? So AI can help, I mean, certainly, but is everything perfect? And my argument is not. When AI comes to our world, one size fit all machine learning or AI can take us only half the distance, and many other things have to be done. And I will give you a very simple dramatic example from self-driving car, which you may have seen media hype quite a bit. If you go to the next slide. And so for example, we'll come to self-driving car in a minute. So many people have acknowledged that the one-size-fit-all AI is not sufficient for many problems, including spatio-temporal. And I'll give you 3 examples. So click, please. So American AI Initiative, and I'm showing the report from last year, actually specifically calls out that spatio-temporal data requires new research in machine learning to deal with challenges such as autocorrelation, spatial variability, and many other issues. Right? Click, please. And given that some of the most innovative agencies like DARPA have actually launched research initiatives. So DARPA had this geospatial cloud analytics, asking people to detect crop health, fracking, illegal fishing, etc., from satellite imagery. And this led to a lot of innovations. So that today the ability to map buildings, trees, and vehicle, and so on, in some sense is an offshoot of that. And now there is another research initiative going on. So click, please. So IARPA is actually looking at sequence of satellite imagery. So nowadays you can get daily coverage from Planet Lab. And if you kind of stitch them together on a common location, you kind of have a video or a movie of that location. And based on that, you can actually detect activities such as construction and classify stages. Other challenges is to actually go underground. As you know, most of the remote sensing only sees the surface. So how do we actually see things inside tunnel and things of that kind? So there are many interesting hurdles in terms of sensing and so on. Click, please, and I'll give you a very specific example. So because of these reasons, we have University Consortium of GIS has actually called for adding geospatial perspective to AI and data science degrees. Please, let's go to the next slide. And to make it very, very specific, let's think about computer vision, which is used to analyze satellite imagery to detect buildings and cars. And you might realize that computer vision community was mostly focused on mimicking human vision. So they mostly look at visual, optical kind of sensing, RGB, and sometimes even LiDAR. But that's not actually adequate. Click, please. So for example, self-driving car is largely built on computer vision technology. And many of you may realize that it cannot really see through bad weather. So if as soon as you have snow or rain or dust storm, most of the self-driving cars will pull over and say, driver, please take over. Because they don't have rich enough sensors. Now think about our own field. Remote sensing, Maxa has probably dealt with much richer sensor, right? Maxa talked about electro-optical, not just optical. This is something computer vision people can learn from us. Click, please. So just to, click, please. So just to show you electromagnetic spectrum, our human eye can see a very narrow band, which is what is called optical or visual. But many of you have actually seen other kinds of sensors, and it will be great to bring that to AI domain. Click, please. So for example, infrared, which you probably saw this night vision goggles in spy movies. Click, please. And so there are these spectrum, and our community has done that quite a bit. In agriculture domain, when we assess plant health, we use infrared to define NDVI and so on. We have 50 years of experience with these kinds of centers. And we have also worked with microwave. If you are imaging things on the pole, there is always cloud cover, and you're not going to see a whole lot in optical band, and we use radar and microwave. So let's click through. As I said, we can bring much richer sensor to AI world, so AI can learn from us as well. Similarly, if you think about Alexa and Siri and things of that kind, if you ask them a geographic question, very simple thing, what's the distance between Washington, DC and United States? Most of us will say 0, and you should try on Google and say what it says. It does not understand that United States is a polygon and Washington, DC is inside that. It converts both of them to point and returns at a distance like 1,300 miles or something. So there are a lot of things we can also enrich AI. And as we work together, so Geo AI is, two-way street. Let's use existing AI to solve some of our problem, but also enrich AI with, with the weaknesses where we have capability to enrich it. Let's click through, go to the next slide. And we see, next few area would be a very fertile area in this. But as we go to societal applications, and our geospatial technology is always interested in that, then we have to think about social science and societal and policy issues. And some of you have actually seen this debate in a very public way. I know many of you may have read the book, Weapons of Math Destruction by Cathy O'Neill, or Automatic Inequality. It actually refers to many examples from AI where there has been major societal damage. But one of the examples is from our own space. And that has to do with crime mapping and crime hotspot detection. Most of the machine learning and statistical technique, they do not account for the social feedback loop. And you are seeing the results in many parts of the world today. If you detect crime hotspots and you place the police over there, then guess what happens to the data next year, right? You are reinforcing the hotspot because police will report from the locations they are placed at, right? So next year, you're going to see those hotspots intensify. And next year, further intensify. And suddenly the communities of, in those locations start to suffer. Minneapolis, we have had really bad fortune even yesterday, related to this. So we really need to think through these societal, issues. And there is a very nice, FATE acronym that I will summarize the debate, at least in the United States and National Science Foundation. So click, please. So these 4 acronyms stands for these 4 things. So F is fairness. So for example, in case of crime, you want to basically ask, is there any bias against gender, race, or age? And if that's the case, are there ways to reduce the bias? Even in geographic sense, there is a bias. As I just told you, the crime reports from police will come from where police is located, right? Accountability. If somebody makes a mistake, who is responsible? And this was brought up with self-driving car. If self-driving car has an accident and somebody is property is damaged or there is a death, then who is responsible? Is the company which made the car? Is it the person who did the software and so on? Transparency is another big issue. Deep learning is used to detect these vehicles and buildings from satellite imagery. But as you know, we don't really understand, it's a very opaque process, right? If you add a little bit of noise, the deep learning will give you something completely different. And I can give you lots of examples of that. So a lot of these neural network and deep learning approaches, it's very hard to explain. If you had a lawsuit, in the court, at least in the United States, you will have to explain it to jury. And if the jury doesn't understand what your deep learning was doing, guess who gets the fines, right? And obviously there is ethics with privacy and so on. In our space, there are some special issues as well, such as modifiable aerial unit problem. In fact, if you're looking at aggregated data, such as census, then a lot of times your results actually depend on the choice of spatial unit. So, we need to understand these issues, and we need to build safeguards, guardrails around AI in order to handle some of these, right? So that's your civil society or academic view. Let's click one more time. Obviously, there is also a business or industry view that innovations is critical. And even though there are some risks, we need to be able to try some new ideas. And for example, in self-driving car industry in the US, they have been, in some sense, the liability has been limited to try some things out. But at the same time, the industry has been asked to be transparent. Tell the driver what your technology can do. When the Tesla founder says that the car will drive itself and people go to sleep while driving and die, that's not a fair thing, right? So industry also needs to be transparent when they're doing this experiment. And we'll click through. The last one is the government, which needs to balance the national security, the prosperity industry view, and civil society. But this is where we all need to come together and come to a consensus and find a common way forward. And those are all of my remarks. Again, thank you everyone for the attention, and look forward to your questions and discussion. Okay, so Barbara, do you want to take over?
Yes, thanks so much, Shashi. And that was a really nice job kind of wrapping up a lot of the things that we had spoken about in all the presentations. So thanks for bringing that home. Listen, I've been trying to monitor the question box, and I have to say that a lot of the presenters have already addressed many of the questions that came up from individual participants. But let me dig just a little bit deeper into a couple. Let's see, one, and I think this will maybe build on, Shashi, your last remark about the self-driving automobiles, where they're, if the weather conditions are such, they do kind of pull over and say, hey, it's time for somebody to take over. And then Stephanie, you maybe touched on it. One of the questions from Ushnish Sengupta was, are there examples of Geo AI projects proactively identifying risks, like maybe bias issues? So do either of you two folks want to build on that a little bit more? Maybe also, Sashi, your last example about, those FATE, fairness, accountability, transparency, and ethics, those standards need to be woven in. So let me just turn to either of you two folks if you want to add anything to Ushnish's question about bias.
All right, Stephanie, do you want to go first?
Well, ladies first is the expression.
Okay.
I think when it comes to the kind of the risk of bias in geospatial, I mean, it's an interesting question because, if you take the fact that, lots of vehicles, of course, now have a in-vehicle camera, right, which is embedded at the front, and that's, used a lot to collect data, which is powering a lot of these applications. Let's say the end result might not, result in any kind of bias, but of course I would say that it's more of an issue for other sectors. I mean, it's a big open question how much of our applications in the geospatial industry would be termed high risk. I don't think it's exactly black and white. So I think there's still a bit of room to dig into this topic in more detail. It's not super clear.
Great. So, so as Stephanie said, it will be easier to take a broader example. And earlier, Lokendra had said everything happens somewhere. So even though something may not look like Geo AI, there is a geographical aspect. So let's take face recognition, right? Which is where most of this bias has been discussed very, very actively. So in case of face recognition, as you know, it was initially built on ImageNet, a benchmark built by Stanford. And they simply went on the internet and collected a bunch of pictures, right? And pretty soon, people started complaining that the accuracy was very sensitive to both the skin, color as well as gender, right? White males, pretty high accuracy. By the time you reach dark-faced female, it was, down to probably 30–40%, right? Now, there is a geographical angle which is not publicly discussed, but, those of us who know NGA, they actually have a very large project, because remember also ImageNet is heavily biased towards Western, right, advanced countries. If you put the face of an Indian bride, you will see what happens to face recognition. I mean, it just goes haywire, right? So actually NGA has been creating a database of faces from all around the world. So they are picking different cultures, different places, and they're trying to make sure that face recognition works in different parts of the world very, very effectively, right? This is a very simple example. Now, the other one, which I would give more as an academic example, but I often use, one of my PhD student is developing what is called spatial variability aware neural networks. Just to tell you a very interesting deficiency of deep learning, right? With all the glory of deep learning and CNN, you should realize that it's one size fit all, right? It's going to learn just one set of parameters for the entire world. And you may realize that doesn't work very well in geography. I can show you two images. One is the snow in Minnesota, and other is the salt land in Western India. It's a very famous salt desert, Run of Kutch in India. And visually, even large number of humans will not be able to tell the difference. Okay? So let alone, what can deep learning do when the humans cannot do that, right? Whereas if I told you the location, if I said this is Western India, you can right away say they don't have any snow, right? It cannot be snow. You have to look for something else, right? So in the same thing, if you go to global agricultural monitoring, the machine learning which works well in Midwest, is not going to work well in India and China, because Midwest, think about the farms. I mean, we have very large farms, very homogeneous farms. It's not that hard to figure out, is it soybean or corn? And you go to India, you go to China, those are tiny farms, extremely diverse. And if you imagine that the machine learning model trained in Midwest is going to do well in India or China, you haven't left the silo of AI and come to the real world, right? So how does GeoGlam do it? Each country trains their own machine learning model. In fact, even the satellite sensors are customized to those geographic areas, right? Spatial variability is second law of geography, which AI has ignored for a very long time. And in Geo AI, we can try to help AI move forward.
Very good, thanks, Shashi. Listen, let's stay on this theme of that maybe came out in a couple questions, and it was specifically the agriculture one about the global north versus the global south. Shiva, I know that, I think in one of your remarks touched on even state and local governments. So even in the global north, if we look at access for state and local governments versus the federal government, you have any advice to organizations, either smaller organizations in the north or, even big organizations in the global south that just don't have kind of the same access to what we're talking about?
Yes, so as I briefly mentioned, so in the National Geographic Advisory Committee meeting recently, some of the DOTs have mentioned that at least at the national DOT, Department of Transportation level, they're starting a program where they want to use AI for solving some of these problems, like road management and then conditions of the roads and things like that. And they want to share that information with other departments of transportation because they have similar problems. They can learn from each other's experience. Even then, again, Northeast road management is completely different from Southwest road management, right? So they need to understand whatever models they develop, they can share them with similar people who have similar conditions, right? So similarly, if you're talking about local agencies, they need to come up with geography-based advisory committees or something that is ties their models or knowledge to a specific location. So even though all of these cities, for example, in US can participate in that, when they look at the data that is available, they should be careful to choose the data that is similar to their geography. So that, as Shashi mentioned, it's very important to understand where the training data, the data models are coming from, and then try to adapt them based on where you are. So again, these are all recommendations and initiatives at this point. So there's nothing concrete. So that's why it's a very good starting point now to talk about these things so that people really get educated about the importance of location, so that when they actually build these associations or data trust, or data models, they really take the location into account.
Thanks, Shiva. Yeah, that's actually a great comment, because as we get down into smaller consortiums or consortia, then it may be easier to either share data, share the training data or the training models that we talked about, that you actually talked about in your remarks. So thank you for that. Smaller groups, there might be more trust to start building some of these consortia where you could advance the whole field, I guess. So thanks. Let's see, Jim or Kumar, anything that you guys want to weigh in from your individual organization's perspective about either things that you think you're going to take on or things, how you see it evolving? I know that in Lokendra's presentation, he did the descriptive and then all the way out to prescriptive at the 5-year mark. That sounds pretty fast to me. So you guys want to weigh in on any of those points, Jim or Kumar?
Jim, you want to go first?
Sure. So there's a lot of free data available to the world. And the real question is how honest, true, accurate is that data? Feeding that data into a model can create disruptions for folks. Shashi had some superb examples of some of the small farms in India and China. And one of the aspects that the world, such as Google Earth, what they probably are missing is the ability to ingest effectively and truly some of the data that comes from these small farmers. So this is crowdsourcing of information, and this is an important aspect for the rest of the world. So South America, Africa, they all need to come up with a model for determining proper and true ingestion of that information to really serve the people as opposed to disserve them. So data veracity is critical. Standards are critical. Global standards are a must. We've seen the disruption to great new technologies by the cacophony of other standards attempting to partition off this part of the world and that part of the world. So Regal is working with governments, universities, other companies to be able to get that discussion moving in the right direction and get on the path to a global standard. Kumar, please.
Thanks, Jim. So from my perspective, Barb, we're actually working to the left of AI/ML to start with. The first one is we use the term analytics-ready data. How do you make sure the data is actually consistent so you can actually run your AI/ML? I think there's a lot of discussion that's going on there. Second thing is, especially with remote sensing, even within the 4 satellites we have today, each of the birds have their own spatial and spectral resolution. So we're actually working on developing a standard. Some of you might be familiar from US called NIRS. We are trying to develop something called AIRS, basically, which is Artificial Interpretation Rating Scale, on what objects can you identify at different spatial resolutions. That's part as our role in the industry. We want to actually promote these kinds of thoughts so that when you see an image, you can quickly say that, can you identify a car at 80 centimeters? Probably not. So we're trying to provide the frameworks there. And then in terms of, as we step back and look at this, one of the key things, and I saw a question about this one, is the reason I mentioned latencies is in the past, data was used for mapping that had months or years in terms of timelines. As we look to the future, especially, there are several military applications I won't go into, but when you talk about human assistance in disaster, the latencies are now, customers are asking for single-digit minutes in terms of getting this data. So we are actually looking at, okay, before you go into AI/ML, what are the processes that ensure that the data is analytics ready, and we can actually go into that. And the last topic is, because of the atmosphere and the changing planet, we are investing a lot of time in synthetic data generation. We want to simulate all the possibilities because there is no way we can collect all this data. So we are leveraging the GANs as an example on creating synthetic data sets so that we can get to this model creation with less number of samples. So that's where we are headed as Maxar.
All right, great. Thanks, thanks, Kumar. And listen, thank you to all the panelists. I really appreciate this. I know we're about to wrap up. Arnaud, I'll turn it back to you. If for any reason we didn't touch on a question that you asked, please feel free to contact us. We'll give you an email address where you can write into the WGIC site. We'd be happy to follow up or connect you directly to any one of the panelists for a more detailed discussion. Arnaud, I'm going to go back on mute and turn it over to you. Thanks.
Thanks, Barb. Thanks for the moderation. Also, thanks, Lokendra. Thanks all the panel members for your contributions. I think you did all an excellent job. Also to the audience, thanks for hanging on for these 90 minutes. So I hope you found this webinar useful. I hope you picked up at least 1 or 2 interesting ideas, insights. As I mentioned earlier, please download the policy paper and read it in full. It's a really nice piece of knowledge and includes a lot of also very practical recommendations and guidelines for both policymakers as well as for the industry itself. So we really hope on behalf of the policy committee that this paper and also the subsequent webinars, and this one is the first one, but we hope there will be others to follow, that this will contribute to a very open debate on the different ways in which we can grow the applications around AI/ML in the geospatial domain, but at the same time ensure that we see a positive impact on society. So I would like to end with a call for action to all in this webinar. So please share your views on the ideas and the policy recommendations that are made in the report. Share these views with Barb and with Lokendra, because this will help us in the policy committee tremendously in our quest to have meaningful impact and ensure that our efforts in developing this report will also have a multiplier effect. So again, thanks on behalf of the policy committee for your attendance, and I now hand over to Andrea for closure.
I thank you very much, Arnaud. I thank you very much, Barbara, and a big thanks also to all of our panelists, as well as to all of the participants for making such an interesting discussions. Before we wrap up, I would also like to remind you that we also will send the report by email to all the participants. We are opening now a quick poll with one simple question. Please answer it and let us know how much you liked this seminar. We also encourage you to check out the AI4Good program online to see more sessions that may be of interest to you. For example, this Thursday, April 15th at 3 p.m. Geneva time, we have the next session of the Trustworthy AI that will discuss auditable AI systems. We are passing the link in the chat and we encourage you to join. With that, we've reached the end of this webinar. And we would like once again to thank everyone involved, our panel, our participants, our partners, sponsors, and co-conveners Switzerland. Thank you very much again and hope to see you again.